Hey, so this is Ru. We have vectors 2 here, and our question reads, on the diagram below, ON is equals to A vector, and OL is equals to B vector, LX is equals to S, LN, and OM is equals to 3A, and MK is equals to 2B. Okay, so we are supposed to actually write LN in terms of A and B, OK in terms of A and B, and then we show that OX is equals to some fraction times A plus 1 minus the same fraction times B, where S is a scalar. Okay, and then we have right here S is a scalar. Okay, and then we have, given that OX is equals to ROK, so R is also another fraction, find the value of R and S, and finally we are going to determine the ratio of OX is to SK. So let's get started here, and I want us to take the simplest approach here of solving this problem. And we have on the diagram ON, and we can see ON is right here and its value is A, OL is B, so LSX is a fraction of this entire line LN, and OM is 3A, OM is 3 times ON, so we have 3A here, and MK is 2B from here to here. So straightforward. You can see that my LN here, I've tried to express it in terms of A and B, and I'm saying LN, we can go LO then ON. Okay, so my LO is going counter the direction of the arrow, and so we take it as negative, and this is where now we continue. We have ON is our A, so we can write this one in a nice way, A minus B. Okay, first solution. Okay, second one, OK in terms of A and B. Now, when we want to express OK in terms of A and B, we need to locate where our O is and where our K is. We move from here to there. So how do we move that? So to move from O to K, there are two ways you can use, but if you move this way, you kind of get stuck because we don't know anything here. So we go to where the vectors are properly defined, and the way is this one. So we use this root. So we say OK is OM MK. So OK vector is equals to OM plus MK, right? So my OM is A, so not A but 3A, and then my MK is 2B. Okay, that checks. So we already have our LN and OK expressed in terms of A and B. So we go to this part of the question that says show that OX is equals to SA plus 1 minus S into bracket times B. Okay, we want to show, and so we are going to use what we already have. So how can we go to OX? We have OX is, OL then LX. Okay, so we say OX, we can go to OL then LX. Okay, fine, so that's LX there. So this is equivalent to what is our OL? So our OL is B, so that's B, plus it's kind of, we know what LX is from here. We know it's SLN. Okay, and that's very easy, SLN. And what's our LN? We had obtained it from this point, so we know it's A minus B vector. So simplifying this, we have B plus A vector S minus B, S, and then so we can rewrite it properly this time around. We have S A, this one here, S A, and we factor B out, so we have B into 1 minus S, and that's what exactly we have here. Okay, so that's done. So we go to, that's the answer to that part. Then we go to part 2 of this B here. We are told, given that OX is equals to R, OK, find the value of R and S. So we have already one way in which we have expressed OX, so we use this second way they are giving us here, and we try to compare the coefficients. Okay, so OX here is R. Okay, what's our OK? OK is 3A plus 2B. Okay, if you're wondering where I've gotten this, it's from here. So that's why it is important to get the correct answers here, because you're gonna need them down here. So we have 3A plus 2B. From there, then we equate this to what we have here, or what we were previously given here. So we have, it's SA plus B into 1 minus S. Okay, quickly. So if you compare them, then we'll distribute and see what our values of S and R are. Okay, so we have 3A vector R plus 2B vector R is equals to SA plus, now distribute, minus BS. Okay, so from here we can see that this one can be equated to this, because we don't have any other quantity that has got A with it. So we compare that and we can see it's 3AR equals to SA. A is common, so we can say that 3R is just S. So that is equation star. Okay, then we compare this one here, B, and these two. So we can say 2BR is equals to B vector minus BS. Okay, B is kind of common, we can factor, and we have 2R is equals to 1 minus S. Anyway, if you factor B here and you rewrite it this way, you get 2R is equals to 1 minus S. Right, that's perfectly legitimate. So we have to now solve. This is star 2, star 1, star 2. So we solve this one and that simultaneously so that we can determine the values of S and R. So we come down here and say 3R minus S is a 0. So I've brought this S to this side, and then this one can be written in a nice way as, 2R, we have plus S is, a 0 here, right? It's not a 0, it's a 1. It's a 1. We have a 1 here. We have brought this S to the left and we have a 1. Sorry for that mistake. So we now add, because we want to get rid of this S here. So when we add, we get a 5R. It's getting messy here. Oops. So I have 1. So 5R is equals to 1, and so R is 1 over 5. That's very nice. So R is 1 over 5, and then we can get our S value right from which step? Maybe from here. We have S is equals to 3R, but we already know what our R is, so we know S will be 3 times 1 over 5, which is 3/5. Okay, so our values are, we use a different pen here, so we have 1 out of 5, and S is equals to 3 out of 5. Those are the two values we need for R and S respectively. We are almost done. In fact, the final answer was, the final question rather was, determine the ratio of OX is to XK. Okay, but we go back to the diagram and see where our X is. So X cuts or divides line OK internally, and that ratio is what they are requiring us to find. So we have to go back somewhere here a minute. So we have here our OX is ROK, but wait, what is our OK? OK is this line here, and our R is 1 over 5 from here. So we say, OX is 1 over 5 OK. This is enough to tell us what the ratios are. So we can say you multiply by 5 both sides. This is the way I decide to approach it. So we have 1 OK. So when you write OX is to OK, the quickest way of looking at this is like, I can block my OK and I block my 5, so I know OX is a 1, right? x is a 1, then I can block my ox and I block my 1 here, and I see that ok is a 5. So I know ox now is to ok is 1:5. Let's see how practical that is likely to be. Go back to the diagram. So we have so what do we have here? We have ox is to ok is 1:5. So we know from here it's 1, and from here to there is a 5. So this must be definitely equal to 4. So what is our question requiring? The question requires determine the value of the ratio of ox is to xk. So ox now, our answer is to xk is equals to 1:4, right? So that's okay. So 1:4, ox is to xk, and that's how that question is done. It's a long question, but if you organize your work properly, you can always get the correct answer. Thank you.